Yes, welcome back. Now we are going to discuss the next data structure, that is queue. So first, what is definition of queue? That we are going to discuss. So queue, again, it is a linear data structure. So just have an introduction of queue, that is linear data structure. Next, it works on the principle of first in, first out, or last in, last out. Next, we are going to discuss the definition of queue. So it is ordered collection of elements. Queue is the ordered collection of elements in which new elements are added or inserted from one end called rear end, and deleted from another end called front end. So this is the definition of queue. So in many books, whenever we are talking about the queue is represented like this. So here I'm going to use the maximum size as 5. So consider or try to assume this is the queue. So here the new elements are inserted from one end called rear end and deleted from another end. So this end I'm going to call it as a front end. Okay. So now we are going to discuss the operations on queue. Operations on queue. So here first we are having insert. We are going to insert new element, delete. The element will get removed, and display, or we are going to call it as a traversing. So these are the three important operations on queue. So when we are going to insert the new element, for example, I am writing insert 10. So 10 will get inserted from rear end. So here the funny thing is that the 10 will get inserted from the rear end, but it will be placed here. It will be placed here. Okay, implementation point of view. So I'm talking about implementation point of view. Next, I'm going to insert the new element. New element is 20. So 20 will be inserted here. Next, I'm going to insert new element. So 30 will be inserted at the next location, and so on. Try to understand. When we are implementing queue, so it is ordered collection of elements in which the new elements are inserted from rear end. Okay, whereas removed from the another end called as a front end. But so whenever we are going to perform a delete operation, and delete does not take any argument, so whenever we are going to delete operation, so obviously which element will get removed? 10 will get removed. So I'm going to change the color of 10. So 10 is red. So 10 will be removed. So implementation point of view, try to understand. Implementation point of view, initially both the pointers, front and rear pointers, will point to the same location. My both pointers will point to the same location. Okay, that is queue of 0. Okay, what is 0? 0 is nothing but the index. Try to understand. Okay, so initially, again, how we are going to implement the queue. So we are having two different aspects for implementation of queue. First, we can use array. So again, array is home for queue, or we can go with the linked list. So why queue is called linear data structure? As we are using array as a home for queue, so the insertion or deletion operation will get performed sequentially. Okay, so that's why it is called linear data structures. So whenever I'm going to insert, new element, again insert 10. What happens? So we have to take care. In previous video in stack, we have to handle, or we have to consider only one pointer, that is top. But when we are dealing with queue, we have to handle rear and front. So when we are going to insert, or when we are going to perform insert operation, we have to handle rear pointer. I'm going to call it as a rear pointer. Okay. So when I'm going to insert new element, my rear will get incremented by 1, and new key element will get added at the rear pointer. So initially, again, the question is, sir, how we are going to assign, or how we are going to initialize the rear? So my rear will get initialized to -1. Same like a stack, or same like a top, rear is initialized to -1. So before insertion, I'm going to increment it by 1. So after incrementing rear by 1, so rear will be 0, and the next value will get assigned here. Q dot rear is equals to key. So dear friends, q dot rear. So what is value of rear? Rear is 0. So q dot 0 is equals to key. So key is nothing but 10. So 10 will get added to the q. So I'm going to remove 20 and 30. Okay. So my rear is pointing here. So I'm going to remove the front. Okay. So my rear is pointing to the 0th index. My rear is pointing to 0th index. So again, next insert operation I'm going to perform. So insert, I'm going to pass 20. So again, rear will get incremented by 1, rear plus plus. So initially rear is 0, so it will get incremented by 1. So rear is equals to 1. So next value I am going to insert to the rear, or rear is equals to 1, or at the first index I'm going to insert the next key value, that is 20. And so here rear will get incremented by 1. So 20 will be inserted here. So in my queue, presently I have two values, two key elements, that is 10 and 20. Rear is here. My rear is pointing to the second. And what is size of queue? My size is 4. Sorry, 5. Max size is 5. So dear friends, so whenever we are going to discuss about insert operation, so we have to take care of overflow. Same like a stack. So here, how to check overflow? So you can see every time we are going to insert, or every time we are going to increment rear by 1. So what is condition for overflow? When my rear is equals to size minus 1. So this condition I am going to call as a overflow. Next, what about deletion? What about deletion? So if we are going to observe this queue, which element should be removed first? 10 should be removed first. So for the deletion, front pointer, I'm going to handle, or we need to handle front pointer. So initially my front is -1. Okay, for deletion, I'm going to increment front by 1. I'm going to increment front by 1. So front plus plus. So if I'm writing front plus plus, my front will be 0. And I'm going to remove the element. I'm going to remove the element. So temporary variable, I am going to use n. N is equals to q of front. Q of front. So what is the value of front? 0. So n is equals to q of 0. So n is equals to 10. So 10 should be removed from the queue. So I'm going to mark it as a red. 10 is removed. Next, what value we are going to remove? 20. So here, for next delete operation, again front will get incremented by 1. So front plus plus. So now my front will point to 1. So n is equals to q of front. N is equals to q of front. And what is value of n? N is equals to 20. So 20 will be removed. 20 will be removed. So if we are going to discuss, or if we are going to see, my queue is empty right now. My queue is empty. Means if I'm going to perform delete operation, so delete operation is not possible. Not possible because of underflow. So how to handle underflow here? So either my front is equals to rear. So if my both pointers are pointing to same location, I can say my queue is empty. So here we can see my front and rear. So initially my front was pointing to this. After deletion, my front is pointing to this location. So here my front and rear are pointing to same location. And I can say that my queue is empty. So not a single element is there. So in this way, we can implement queue with the help of C or C++. Okay, as we are using array as a home for queue, you can implement the queue with the help of structure. Okay, structure data type. So what is structure? So how it is defined? So how it is defined? Struct queue. Struct is a keyword. Next, integer array I'm going to use as max. Here I need to define integer front, integer rear, closing, and so this is the structure representation of queue. Similarly, we can represent a queue or implement queue by using classes. So class, name of the class will be queue, opening bracket. Next, obliquely, I'm going to define. So you can use any access specifier. So integer queue will be the maximum size is max. Integer integer uh, front, integer rear. Okay, and here you can write down the methods. Void insert integer delete or nq and void display. You have a choice, either you can define these methods inside the class or outside the class. Okay, so in this way I'm going to conclude the queue linear data structure. Thank you.